Okay, so we've got 2 blue chips, 3 red chips, 5 total. There are 2 possible outcomes when Andy picks his chip. He can either pick a blue or he can pick a red. And so we want the probability of each of these outcomes. So the probability of picking blue is 2 out of 5, and the probability of picking red is 3 out of 5. Now what happens when we get these is if Andy picks a blue chip, Sammy gives Andy $2. So Andy would come out $2 ahead. So he would gain 2. But if Andy picks a red chip, Andy gives Sammy $1. So if a red chip is picked, Andy would lose 1. So your expectation, you're just going to multiply these, and add them together. So you're going to do 2/5 times 2 plus 3/5 times -1. So that times that plus that times that. And so if we do this, we get 4/5 minus 3/5, because remember these are all over an invisible 1. So 2 times 2 is 4, 5 times 1 is 5, 3 times -1 is -3, 5 times 1 is 5. So 4/5 minus 3/5 is 1/5. So Andy's expectation is 1/5. If you do 1 divided by 5, you get 0.2. So like 20 cents. And all the expectations should add up to 1. So when they ask us to determine Sammy's expectation, we're expecting Sammy's expectation to be 1 minus 0.2 to be 0.8. But just for more practice, we can set up the same table and see if it works. So the 2 possibilities for Sammy is he could still pull blue or red, and we could find the probability of each. The probability of him pulling blue is still 3 out of 5, and the probability of pulling red is still, no, blue was 2 out of 5, sorry, and red was 3 out of 5. But the X is different. This time, if Andy picks a blue chip, Sammy gives Andy $2. So Sammy would be losing $2. So this, for Sammy, that would be a -2. And then if Andy picks a red chip, Andy would give Sammy $1. So Sammy would be gaining $1. So his outcome would be +1 here. So again, to get at your expectation, I'm just going to multiply these, add them together. So you have 2/5 times -2 over 1, right? Plus 3/5 times 1 over 1. So you get -4/5 plus 3/5. So you're getting -1/5. So you're getting -0.2. And that actually makes more sense. This here, ignore that, what I said in the very beginning. Your expectations shouldn't add up to 1, they should balance out to 0. So if his expectation is to win 20 cents, then his expectation is to lose 20 cents. So sorry about that, ignore that. Ignore what I said first. Okay, wipe that clean. So, got both answers. So you've got 8 with $2 off, 3 with $3, 1 with $5 for 12 total. So you make a chart of your possibilities. You could either choose $2 off, or $3 off, or $5 off. Your probability of each of these, there are 8 out of 12 to get one of those, 3 out of 12 to get a $3 off, or 1 out of 12 to get $5 off. And your profit, here you get $2 off. I'm just going to do it all in positives. It doesn't really matter. Yeah, so $2 off, $3 off, $5 off. So your expectation, this times this, plus this times this, plus this times this. So 8 over 12 times 2 over 1, plus 3 over 12 times 3 over 1, plus 1 over 12 times 5 over 1. So 16 twelfths plus 9 twelfths plus 5 twelfths gives you 30 twelfths, which gives you, what was that? It's 2 and 6 twelfths, so 2.5. So you're expecting to get a discount, an average discount of about $2.50. Okay, so in our first envelope, there are 2 $5 bills and 1 $10 bill. In our second envelope, we have 1 $5 and 1 $20. So we're going to try to draw a tree diagram. So first things first, we're going to pick from our first envelope, and we have the possibility of either choosing a $5 or a $10. And if we want to put some probabilities on this, the probability of drawing a $5 bill would be 2 out of 3, right? And the probability of drawing a $10 would be 1 out of 10. Now we go to our second envelope, and we could pick either a 5 or a 20. So I could pick either a 5 or a 20, and for this one, I could pick either a 5 or a 20. And the probabilities for each of these, I've just got a 1 out of 2 chance of getting the 5 and a 1 out of 2 chance for getting the 20. So I could label these half a chance for those. Not sure if he needs all that, but we got it. So now, if we want to write out the members of the sample space, we can just read it off the tree. We could pick a 5 and a 5. So a 5 and a 5. We could pick a 5 and a 20. 5 and a 20. Or we could pick a 10 and a 5. Or we could pick a 10 and a 20. So these are the members of our sample space. And then for part C, find the probability of getting 2 $5 bills. All we have to do is look at our sample space and see that we have this outcome is getting 2 $5 bills. And so here it's going to help that we labeled these probabilities here, because the probability of getting a 5 and a 5 will just be 2/3 times 1/2. So I'm going to do 2/3 times 1/2. Let the 2's cancel, and I'll get a 1/3. So that's for part C, just the 2/3 times the 1/2 to get the 5 out of 5 probability. For the last part, find the probability that 2 bills picked adds up to more than $10. So we take a look at our outcomes, and which of these add up to more than $10? That one adds up to 10. We want more than 10, so we'll take this one, and that's 15, so that's good. And we'll take that one, right? So notice we added all of these except for that. So the probability, because we already found that probability, we could do the probability of getting these is 1 minus the probability of getting that. So we could say 1 minus 1/3 to get 2/3. And that would be our answer for part D. Another way of going about it is to find the probability of each one of these, just like we did here, add them all up, and that should agree. So let's try that too. So the probability of getting 5 and 20 would be 2/3 times 1/2. So 2/3 times 1/2, again let the 2's cancel, you get a 1/3. The probability of getting a 10 and a 5 would be 1/10 times 1/2. I think I meant 1/3 there, right? Sorry about that. Good thing I checked that. 1/3. 1/3. Because that was the probability of getting a 10. There was 1/10 out of 3. Okay. Good thing I did this. So 1/3 times 1/2. 1/3 times 1/2 is 1/6. And this one here, 1/3 times 1/2, is another 1/6. So if I add up the ones that I want, this one, and this one, so 1/3 plus 1/6 plus 1/6, 1/3 plus 1/6 plus 1/6, get a common denominator of 6, so multiply this guy top and bottom by 2. That's 2/6 plus 1/6 plus 1/6, which is 4/6, which is 2/3. So we match. Excellent.